Next, I want to take you to my component board to show you the parts that's involved in the air conditioning electrically. We're going to start with the parts. This is my safety switch. I have a fuse. We're using 120 volts here for this DVD so that I can plug it into a receptacle rather than when you're out in the field, you're going to be dealing with 240 volts. But what I'm doing, I'm bringing my power into my transformer. Now it's a 24 volt transformer for the simple reason we're coming over to our thermostats, and you can see here we don't want 240 volts on our thermostat. We want something safer, a lower voltage, because people are going to be touching this and adjusting it and flipping switches, has arcing, etc. So you can see here as a technician, and eventually you'll have this memorized. The red wire's power, the yellow will be air conditioning, the white's heat, the green's your fan motor. This thermostat is like the brain. Like, you know, if it's too hot in the house, you want some air conditioning, you're going to flip it to cool, vice versa to heat. So this is going to tell all this what to do. But what we need to do now is understand the parts. Now see, the parts is transformer, thermostat. This will be our contactor. You'll see on the schematics when we do it later, when I take you through the schematic drawings, you'll see this as listed as a C, contactor. What? When it energizes, it's going to come start our compressor. I'm using this blue light bulb as a compressor. You'll see it eventually blinking like it's pumping. Then this one here is the control relay. On your schematic, it'll be marked CR, so that when I turn the thermostat, things are going to happen, like the CR is going to energize the contactor, it's going to start this. Now this is our condensing fan. This is outside. Our fan, you'll see it spin. This is our indoor fan, sometimes called the blower. It's like in your furnace room. This is what's blowing the air out through your house, through the ductwork. When we get to heat, like say it's a cold day and we want some heat, I'm going to use this thermostat down here and I'm going to flip it, and what's going to happen, this light will be a gas solenoid. When it comes on, it means I'm sending a signal to the gas solenoid to ignite, and your heat exchanger will start heating up. I don't want the fan to come on yet. Why? Well, it hasn't heated up enough, the heat exchanger. But when that heat exchanger reaches temperature, like there's up in the plum, there's a temperature switch. Generally, they're around 90 degrees Fahrenheit. So when this heat reaches 90 degrees Fahrenheit, now the fan comes on and I'm blowing warm air through the ductwork instead of cool air. So until this heats up, I have cool air up in that duct. So I want it warm when it comes out. Now, when I reach temperature and the gas valve shuts off, this fan will continue to run until I get down to that 90 degrees Fahrenheit. Then the fan will shut. Why? I still have, the heat exchanger still has warmth, and I want that warmth to blow it out. That's why I want the heat. Now, some have asked, well, what if the fan didn't come on? What if it just kept burning and burning the gas in the heat exchanger to where it got so hot it melts or ignites the house? Well, see, you'll see later there's a high heat bonnet. It's like a warp switch, works on temperature. You even have it in the electric heat. You'll see it in that compartment. In case something doesn't happen, it will shut it off to prevent a dangerous situation. Now, you're going to have safeties, like up here on the compressor. You'll see in a moment, we're going to show you pictures of all this stuff. But you'll see in series, you have a high pressure switch, a low pressure switch, and a thermal overload. And we'll show you pictures out on the unit so that when you see it, you'll say, yeah, there's the high pressure switch, here's the low pressure switch. And Tim, my son, I'm going to take you through the mechanical part, you know, the freon and the gas and all these valves and pressures and this stuff. I'll take you through that. Show you also where this is located on the unit. What I have here is a parts board, components electrically, say, so that you'll see in a moment when one of these opens, it's a safety to protect from damaging the compressor. Okay, compressor, outdoor fan, indoor fan. Now on the resistance, So here comes what we call sequencers. Now this little sequencer, it has a little warp switch. You'll learn more about it in the book you read. We even show pictures. Like what you have to remember, the way I was taught, if I wanted to get this ring off, it's tight. I would take some ice and I'd put ice around it. Why? It's going to make it shrink. Cold shrinks. Heat expands. So that's what you're going to learn here. Well, on this warp switch, when we heat it, it's going to expand. It expands, it's going to make contact. When it makes contact, it's going to send a signal like, give me some heat. You'll have another one bring in a second layer of heat. Or you may have an industrial, you may have 3 or 4 or 5 of these strips. Don't want them all at once. Why? It's too much current. Too much current drawn instantaneously can trip the breaker or blow the fuse. So we're going to bring them in a sequence. See, this is what this is all about. It's called sequence. When I worked in the industry and they called me up to work on a machine, you know who the best person to talk to was? The operator. Why? He knows the sequence. And once you know the sequence, you know what's supposed to happen and what isn't happening, then you know right where to go. And what we're going to do later on this video, we're going to troubleshoot these things. We're going to put problems in here. We're going to take the meter and we're going to go from here to here and here to here. And we're going to walk right through that schematic to where you'll be a qualified technician. In other words, when you go out to troubleshoot a house, you don't want to be a parts changer. You know, there's a lot of them out there. You don't want to be a buddy nobody. You know, you want to be a skilled technician. So what you do, you can say to the customer, what you had here was an interlock. It was a little burnt. I filed it off. Right now, you don't need a whole new relay. Maybe someday, but not now. I'm not even going to charge you. You know what I mean? That's the way you do business, is through your reputation of being a good service person. What I want to do now is show you the sequence of operation from the thermostat. Say it's the first cold day in the fall and it's getting cool in the house and you need some heat. And say you have a gas furnace. Now this is going to be our gas solenoid and this is going to be our indoor fan. What I'll do, I'll come over to my thermostat and see what the temperature is in the room. Wow, it's cool in here. So I'm going to flip this to heat. When I flip it to heat, I've sent a signal to that gas solenoid to energize, let the gas out, the igniter fires it, the heat exchanger is warming up. This fan won't come on until that heat exchanger reaches about 90 degrees Fahrenheit. There's a temperature switch up in the plum that you can set, but generally they're around 90 to 100 because I don't want to blow cool air out through the house. So as this heat exchanger warms up, reaches that temperature, wham, the fan comes on. Now I'm blowing my warm air out through the house to heat it up. This thermometer on there, the thermostat, when it reaches temperature, I set it on 80. Okay, when it reaches 80, this will shut off. Let's see. I'm going to bring it down. Gas shuts off. But guess what? Fan's still running. Why? The heat exchanger is still warm. I want to keep blowing that warm air until it gets below 90 degrees. And when it gets below 90 degrees, bring her down. Why? I don't want to blow cool air back out through the house. I want warm air. That's your gas. Now, say you don't have gas in your neighborhood, but you go to the resistance electric heating. Like I said earlier, these are your nichrome heating elements, high resistance. I'm going to put 240 volts on them. But I don't want them all to come on at the same time. Too much amperage. So we put these sequencers in here. These little sequencers, like I said, are warp switches. When they reach temperature, wham, they close. I'm going to use this in place of the heating element. When you see this bulb come on, it means one heating element just ignited. But now I want this fan to come on the same time. Why? If I put 240 volts and heat these things up, I mean, they get like white hot. I'll melt them. I've got to have some air blowing across them. So it's very important that this fan starts at the same time. So what I'm going to do now, I'm waiting for this sequencer to warm up a little bit. And when it warms up, it's going to close, and it's going to bring in this 240 volt. See that start at the same time? There wasn't any delay. It was like now. I have one unit on. I've got hot air instantaneously. I don't have a heat exchanger. I have heat right now. So I'm blowing heat out through the ductwork. Now this brain over here is saying, wait a minute, it's not coming quick enough. I need some help. Give me some help. So another one comes in. You may have 1, 2, 4, it depends on the kW of your unit. Now I got both of them going. I'm putting hot air out. Everything's getting warm. My thermostat's getting close to temperature. When it starts getting close in this range, show you how smart these things are. They're going to say, hey man, we're getting close. Let's take one of these out of the picture for now. We got a little bit too much heat coming at us. I take this out of the picture. I still have one element heating. Fans blowing the air. But now I'm saying, you know, I'm getting close. I'm getting close. When I start getting close to the preset temperature, I'll take this out of the picture. I'm almost there. I'm waiting. See, this is all time through the brain. I've taken it out. Fan's still running. Why? Because I still have warm air up in there. I'm putting the warm air out through the house until I get down to that. When I get down to there, cut. We got it, right? That's your electric resistance heat sequence. You have to know the sequence of operations and controls. That's what's important about this book and this video. Like on this video, we're going to come back later and set the old meters up here, and we're going to check the capacitors. Remember, the capacitors is what keeps this thing starting and running. So we're going to do tests. We'll show you a good one. We're going to show you one that's defective so that you'll know. You can say to the customer, all it was a capacitor. I didn't have to put you in a compressor. These are expensive. So anytime you can save the customer some money, do it. That's your reputation. That's what makes you a professional instead of a parts changer, okay? Now, let's say it's warm. It's warm in the house. I need some air conditioning. Well, here's our compressor. Remember the safeties. Here's our outdoor fan, our indoor blower fan. We use it for heat or air. So I come over here and I set my thermostat. Let's say I want this thing cool in here. So I'm going to bring it down and call for some cooling. Fans are on. This should start pumping. Indoor fan, outdoor fan, compressor, all three ignited. I'm making cool air coming into my house to bring us down to the setting I put it on. That's your sequence. What happened was, when I went to cool, you'll see later on the schematic, when I walk you through it, the control relay, got the signal. See the yellow? That's a yellow off the thermostat. Yellow's cool, remember? Red's power, green's fan, white's heat. White. White is what come over to this guy and this guy. But right now I'm talking about air conditioning, which is yellow. I fire the control relay. When it picks up, guess what? It energizes the contactor to start the compressor. Compressor's running. But as you're going to learn on the schematic, and when you troubleshoot, say the compressor isn't running, or it runs and it stops. What if it's a high pressure switch? That stopped it. Remember, they're in series. Or say, it's all right, but guess what? I got a low pressure problem. It stopped it. Or guess what? The thermal overload. It's a protection for the compressor to keep it from, say it locks up or the bearing starts dragging or you got a resistance on it mechanically. This thermal overload says, man, it's hot in here. Something's going bad's going to happen. Shut her down. Shut it down now. Shuts the compressor down to keep from burning it up, from damaging it. They're expensive. But what you have to learn as a technician is All three of those are safeties. They're to protect that compressor. Well, if that compressor isn't running, it's up to you to determine what happened. Why isn't it? You know, that's your job as a technician, to go through all this stuff and to learn it. We're also going to later on this DVD, after I take you through the schematics and all that, we're going to come back and we're going to troubleshoot. In other words, you get a service call, hey, my air conditioner doesn't work. Well, here in Florida, I'll tell you one thing, it's like a survival kit in the summertime. You have to have air conditioning, same way in Arizona. But watch, you may call the air conditioning service guy and he says, hey, we're busy, I can get there in 3 days. No. Now, what's going to cost you? Well, I got to send a guy over on overtime this evening. Do it. So when you go over there as a service technician, you got to troubleshoot. That's what we're going to teach you on this book and this DVD, is how to troubleshoot. My son Tim, later on, he's going to take this meter. We'll show you the analog meters with the needle, as you read in your book. Or we're going to use a digital meter. And we're going to check the capacitance on these capacitors. And we're going to show you some bad ones. You know, the side gets all bulged, and you can just look at them and say, that baby's bad. Or we're going to show you good ones. And we're going to show you the difference in capacitance, which affects how the compressor works. Okay? Then watch. We're going to give you tips. Here's a tip I like. Say you go in and the unit's not running, nothing's happening. What you can do, I mean, you can go out to the breaker panel and look for circuit breakers that are tripped, or you can go to the fuse box, see if any fuse is blown. Or you can do something real simple. You can go to the thermostat, it's on or off. See where it says fan? That's this guy. That's your indoor blower fan. And it says on or automatic. Generally, it's an automatic for your air conditioning and heat. Yeah. But here's what you can do. If I flip that to on, see that fan run? You know what that tells you? I got voltage here. My transformer is good. My transformer is putting out 24 volts. See this green wire? See the green wire up there? Remember, green is fan, red's power, white's heat, yellow's air conditioning. These are wires that someday you'll memorize. You'll fall asleep thinking about them. Okay? So we're going to give you lots of tips